Bill Nye the Math Guy. Bill Nye the Math Guy.
Bill Nye the Math Guy.
Math rules.
Bill Nye the Math Guy.
Multiplication is part of an equation.
Bill Nye the Math Guy.
Bill
P-Rad to the green.
Bill Nye the Math Guy.
Oh, yeah, just watching the view. Do you know that everything is made of by oblique angles and oblique triangles? Well, come on, you see. Today we will learn a little bit about oblique triangles. Come on. Also, we will learn about triangles, right triangles. And also, we are gonna learn about graphs. So you see, come with me, come on. So you see, in the graphs, we have the sine and the cosine. So, in the sine, the things go like from the top to the bottom. And then on the cosine, the things go down. You see? Come on. Okay, as I was telling you, we will have our friend Maria, our friend Fatima, and our friend Valeria explaining us these things detailed. So you can see, for example, this plant is beautiful. So if this plant begins its journey from the top, as I previously said, it's a cosine. But if then it begins its journey from the bottom, it's a sine. Also, for example, let's put angles. Where you can find angles? Let's look. Oh, you see here? You can see here. There is a right angle. So here is a triangle. Also here, another right angle. Another right angle. So you see there's triangles everywhere. You see? Here's a triangle. Come on. Oh, I was just reading this book about angles. So let's go to our friend Valeria so we can explain something about the angles. Oh, no. Very much. Well, I'm here with my friend Valeria and we will show you something about the Cartesian plane and the angles. So, you see, let's get ready. And then Valeria will explain you the Cartesian.
Okay guys, so let's just imagine that this one right here is the x-axis and this one right here it's called the y-axis. So if you're in the x-axis and you go all the way up, that would make it a positive angle. So if you go all the way downwards, that would make it a negative angle. Either way, positive or negative, if that angle is a multiple of 90, it will be called a quadrantal angle.
So so what you're saying is, if I take this ball and I hit it and it travels all this way, it's 90 degrees, right?
Right.
It's positive 90 degrees.
Right,
so
because it's going all the way up.
that will be a quadrantal angle because it's 90 degrees.
Yeah.
So then again, if I hit this ball and then it comes back again to here, it travels 180 degrees. That's
Yeah.
still a quadrantal angle?
Yeah.
Yes?
Yeah.
So again, if I hit and then it goes all the way and it goes back to the beginning.
It would still be 1 because it would have traveled 360 degrees.
Ah, okay. Oh, perfect. I understand. Well, so we already explained you 3 types of angles. Now we're going to explain you the other 3 types. So let's go over there to the table and I'll show you. Come on. Here I have some pencils and scissors so I will explain the Cartesian plane again. So we're simulating here a Cartesian again.
So let's say we're given a 150 degrees positive angle. And if our x-axis starts right here in the 0, that would mean it would be all the way up here, 150. Now, you see this little space? Well, here we would call it a reference angle if we get from where it ended to the x-axis again. Meaning, if this whole thing is 180, we will subtract the 150, leaving us with a 30-degree reference angle. Now I'm going to tell you about the coterminal angles. So this can either be negative or positive. How do we get a positive coterminal angle? Well, that's really easy. Just start from the 0, right where you started with your normal angle, and you go all the way to 360 degrees until it actually reaches the angle you were left with. This meaning adding 150 to 360, giving you a 510 degree angle. Now, what do I do if I want to get the negative coterminal angle? You will start from here, and as you remember, if you go downwards, that would make it a negative, and that's what we are looking for. So you go all the way here, which is 180, and then you add up your reference angle from the beginning, which was 30, which adds up to negative 210, which is your coterminal negative angle.
Now we have explained the 5 different types of angles they are, so let me give you a small resume. You see, we have the positive angle, which is the angle that goes counterclockwise. Then we have the negative angle that goes clockwise. Then we have the quadrantal angles, which are multiples of 90 degrees. Then we have the coterminal angles, which are the angles that give you the same angle, but there is a positive and there is a negative. And now, we have, at last, the reference angle, which is the angle that goes from the angle to the x-axis. Now we'll go with our childish friend, Maria, I can see, and she's going to explain about obtuse angles. Oh, and yeah, she's a 12-year-old girl. I told you.
I'm gonna explain obtuse triangles.
Oh my god. Oh my god.
So I'm gonna explain obtuse angles, and here's how I'm gonna do it with this piece of paper and pen. As you can see, here we have an obtuse triangle because it doesn't have a right angle. So there are various formulas you can use to get the angles and the sides for this kind of triangle. First, you can use sine law. This is usually used when you have couples. For example, an angle here and a side here, or an angle here and a side here, or an angle here and a side here. You need to have couples. So this is how it's used. If you want to get the angle, you need to put the sine A on the top with the side on the bottom equals sine B with a B on the bottom. Imagine you want to get sine of B. So you're gonna do this. You're gonna put sine A and the B multiplies. So you're gonna pass it here over A. Sine of B is left. But how do you isolate B? Simple. You're just gonna pass the sign over here as an inverted sign over the whole thing. And that is how you isolate for B and get angle B. But if you want to get a side, it's a little bit different. First of all, the sides go on the top. And you do the same thing, but the whole thing is going to multiply. So you put A sine of B over sine of A, which equals B. And that's how you get the sign with sine law. Cosine law is used when you do not have a couple and you cannot use sine law. And here are the formulas. A squared equals B squared plus C squared minus 2BC cos of A. Or B squared equals A squared plus C squared minus 2AC cos of B. Or C squared equals A squared plus B squared minus 2AB cosine of C. These are the formulas, and you use them like they are if you want to get the sides. But if you want to get an angle, you just switch them a little bit. For example, A squared equals B squared plus C squared minus 2BC cos of A. First, you pass the B squared and the C squared subtracting. So it's going to be A squared minus B squared minus C squared equals negative 2BC cosine of A. Then you pass a negative 2 and BC dividing because they're multiplying with cos of A. So it's going to be A squared minus B squared minus C squared over negative 2BC equals cosine of A. And as I explained before, the cosine is going to be inverted. So you put cosine inverted a squared minus b squared minus c squared over negative 2bc equals a. And that is how you get an angle using cosine law. See? It's really simple. A 12-year-old can do it.
Go! Woo! That's why I'm a math teacher. You see, she's sleeping. So now we're gonna go there. Okay, come on with me. Come on. Come on, come on, come on. Now I can take this. You know, that was a childish place. So let's go and let's keep teaching some math. So funny. Well, let me show you about graphs. So here my friend Fatima is going to explain a little bit about graphs. Here I have this scale, so you know. Well, there is. Let me take out this and let me show you an example with a cable. So let me pass this and Fatima will explain.
Okay, so here is the, like, this will be like a plane. Okay, so I will explain this formula.
Okay, so here we have an example of the replication we already made with the chord. Then
So
3 in,
this
this
is
is
the
the formula.
formula.
Is fx equals 2c.
Hay que después hablar.
Ahorita no estamos abriendo.
B plus b minus c equals d.
Por correo.
So then we will explain what is a. Well, a is how tall it is from the middle. So there you go to the middle, then you go up, and then you go down. So the amount of the numbers you go up, it will be the same as you go down, and that will be the amplitude. Then we go to sin. So sine is whether it starts at the top or it starts at the bottom. So sine will start at the middle and go up. Then cos will start at the top and go to the bottom. Next, we will go to b. So b is the amount of waves there are in 2 pi. So in this case, we only have 2 waves. You see, 1 wave, 2 waves. There we have 2 waves. Then we'll go to c. C is the displacement in the x-axis. In this case, there is no displacement, so there is no c. Then we will go to d. D is the displacement in the y-axis or in the vertical line. So in this case, it's displaced 1. And then that's it.
Yeah?
Bill Nye the Math Guy. Bill Nye the Math Guy.
Bill Nye the Math Guy.
Math rules.
Bill Nye the Math Guy.
Multiplication is part of an equation.
Bill Nye the Math Guy.
Bill.
He rad to the green.
Bill Nye the Math Guy.